Video, I'm going to explain how you can design integrator using Opamp. You require one Opamp, dual power supply plus VCC and minus VCC, and capacitor in the feedback path, and R1 resistor, and signal generator. This is function generator, and you have to give a square wave. So you can give sine wave, triangular wave, and square wave, and you have to give frequency of 500 hertz. Okay, amplitude is 5 volts, 50% duty cycle, that is on time is equal to half, and one oscilloscope and ground, and one more resistor here. So I will show how to do this. Click a file, new, and can zoom a little bit. So now I'm going to place Opamp. Go to place component, and you can go for all group and all families. In the Opamp, you type Opamp here. In the component search, type Opamp. You can see you select Opamp rated. So I want negative terminal at the top. Okay, I want negative at the top. So you have to flip vertically. So this label, you click on only label and you drag this one to here. So right click and click flip vertically. Now negative terminal is here. Actually, I want flip horizontally also. No, no, no. Wait. Okay, negative terminal at the top, plus terminal is here. Okay, now I want one capacitor. This component. Group, you select basic, select the capacitor and resistors. One resistor here and one more resistor at the output side, and capacitor. Capacitor, you can select 1 microfarad, 1 U. P means pico, 1 U means micro. 1 microfarad is over. Next, I want function generator. It is available in the right side most. One vertical menu is there. There, first one is multimeter, second one is function generator. You can select this. You can also give using AC source also. Okay, I can go to place component, power sources, AC sources. You can select and give. Better use function generator. So next, we have to connect this resistor here. We have to connect the power supply also. Okay, now this common is actually ground. So input should be given to common is actually the ground. So now I have to press ground also. You can click here, place sources. This is shortcut actually. You can go to place component, select source group, or directly you can go here. So one ground here, one more ground at the output, and one if you want you can connect to here also. And in the power source only, VCC and VE is there. Click on VCC. The terminal nearer to the plus is actually you have to give VCC, and the terminal nearer to negative terminal, inverting input terminal, you have to give negative. We can use 5 volts, or you can also use, you can give the power supply of 5 volts or 12 volts or 15 volts, 9 volts, anything. Wherever you want to turn, you have to click one more time and you can. Now connection is over. Okay, it is integrator. Integrator is same as inverting amplifier type. Instead of RF feedback resistance, you have to replace by capacitor. Okay, so this is a integrator. If you write capacitor here and R here, that becomes a differentiator. So in the integrator, feedback is capacitor. Feedback path is capacitor. And this double click on the function generator. By default, sine wave will be there. You click on square wave. Frequency, you change it to 500 hertz. Okay, amplitude, change it to 5 volts. Okay. After that, you click close here. So now actually square wave is giving as an input. Output, expected output is actually triangular wave you should get here. So in order to see the output waveform, again go to the right side. You can have one more menu. First one is multimeter, second one is function generator, third one is wattmeter, fourth one is oscilloscope. So here output you connect to the pin number 6. Change the color to, right click, change the color tab to, otherwise all will come in red color only. Again input also I want to see. Input you can connect here only. So let me change this color to, right click and change segment color. I'm giving green color. And I want to connect on ground also. If you want, you can connect these two to this ground path only, or I'm going to connect one more. Copy this one, Control C, and paste here. And both the grounds of both the channel A, channel B. Okay, in the lab also you can see oscilloscope. CRO means cathode ray oscilloscope. It is the output device. It will give the visual representation of any signal. So in this is a virtual oscilloscope. Here also you can see 2 channels are there. If you want 4 channels, you can go there and you can have 4 channel oscilloscope is also there available, where you can see at 4 different points of the circuits you can check all the outputs different points. Okay, now this is over. Now I will double click on this. So expected output is what? Input is actually square wave. Output is actually triangular wave you should get. So you have to click run button now. After run only you have to double click on this. Now can increase time base, you can reduce to 5 millisecond, 2 millisecond to 1 millisecond. And after that, you can click on single. Okay. So this is how you can get a triangular wave with the help of this one. If you give sine wave, integration of square wave is actually triangular wave. Integration of sine wave is actually cross wave. I'll show you. You can see this is the output. This is by default, if it is in black color, reverse, click on reverse button. So this is output. So you have to make a report means you have to click print screen. You have to click print screen in your laptop and you have to copy only waveform and you have to copy only circuit diagram and everything. If you click print screen, it will be copied to clipboard and you have to paste it in Word file or in Paint, anything. So you have to drag how to copy this like this. It will copy this, and after that you can paste to your report. Okay. Now, if I will show you how to change the waveforms also. You have to stop simulation. By default, it is sine. Now I change it to square wave. Now I will change it to sine wave. So that integration of sine, you should get cos. Okay. Now I will rerun. See, output. Input is sine wave. Input is sine wave. And output you are going to get cos wave. You can change the scale division. Okay. And what happens if I give triangle wave as the input? Let us verify. The simulation now we can have to simply have a curiosity that what is the output of expected output. Now if I run this, stop it and rerun. If I give triangular wave, output is, I think it's coming some sinusoidal only. Is not stopping. Yeah. This is just for some use this. So change it to square wave and rerun it. So that is the output, actual output. So function generator I showed where you can change this output. So here I changed the scale. Okay, scale division I changed it to 5. That's why it's coming like this. So this is the output. Thank you. You can label here. Okay, that is option. If you want, you can place text here. You can write here Opamp as an integrator. Integrator using Opamp. Okay, and you have to take a screenshot of output also. Thank you.